Hello, my name is Samuel Bogwa, and I'm going to be presenting my presentation on video game physics. Okay, talk about game engines. The well-known game engines right now are Unity, Godot, Unreal, or GameMaker Studio, Construct, and there's many more. These game engines use their own physics engines. For example, Unity has its own physics engine that they use. Godot has a Vulkan renderer, Unreal, and all those other ones I don't know, but they all use their own physics engines. How physics engines work, they allow us to simulate how objects would react when a force is applied to them. And these forces could be like constant forces like gravity or a constant car's momentum. How you would implement physics in these game engines, you would have like an object that you create or an object that is already pre-built and you just have to place it in. For example, in Unity, you could just make a ball, and then you put a component of the type of bodies you want, like kinetic, static, or rigid body. And some engines have dynamic bodies in theirs as well. And these bodies could, like I said, either be components that you can put onto the body, like in Unity, or the separate objects which are nodes, like Godot uses. Okay, so this is a 2D example I'm going to be showing. So here you see me creating a circle, and we're just going to be putting it into our scene. And as we see, if we basically just run this, it's a static object. Nothing's happening to the object because we haven't set what type of physics body we want to use. So in here, I'm going to be using a rigid body for this example. And see this rigid body, you could see there's gravity scale, angular drag, masses, and these forces could be changed whenever you want. And you saw that as it ran, there was a problem because we didn't have a collider, so it's passing through the ground. So with the collider just touches the ground now. So we're going to be adding a physics material so it simulates like an actual ball that's bouncing instead of having it just slam on the ground. So if we put it to 1, you see there's a problem and it keeps bouncing forever and doesn't slow down, because with 1 it just basically means it's infinite, just going to be infinitely gaining speed. And if it's there, we saw that once changing it to 0.5, it worked perfectly fine as we wanted. So here I'm programming just adding forces, so we could show you how you could add forces to these components. And I'm going to be adding a force, and with this see that I'm loading it so you could change the direction with the vector 2 and then multiplying it by a certain speed that we want it. And then the force mode, we're going to use impulse, so it applies the force immediately. And then, so here we're changing the force mode to force, which basically applies the force slowly, like additively. And our force is very low, so it's not going to be as fast as the previous example. So if we change it to 100, it's going to be a little faster, but it's not as close to the impulse version, which is instant. So we're gonna go back, change it to impulse, and show you that these two modes are different, and you can use them however you may like. So here we're gonna go to 3D and then show you how we can take a 3D object with the rigid body and apply its forces. Here I'm basically creating a shoot function which basically creates the projectile, in our case a cannonball, and shoots it from the beginning of where the ball is supposed to come out from the cannonball. And here we're just using the same forces, but we're using a vector 3 instead, which is a 3D vector. And I'm going to be multiplying it by our projectile speed. Later on in this, I'm going to change the 3D vector so we could change it in the Unity editor, and so we could easily find where and how we want our cannonball to be shot. Gonna see it shoots correctly, but not in the right spot as we want it to. So I'm changing it back to position, so it shoots from the position of the cannonball, and there, as you see, it runs perfectly. And as we hear, I'm setting it up so we could change it and run the program at the same time. So yeah, that's my 3D version, and thanks for watching this presentation.